Good morning, class.
Good morning, ma'am.
So today we will be doing ISA Project 1 International School Award Project 1, and the title of the project is Time Quest Calculation of Longitude and Time. And the partner school is Aspire Academy from Hull City. Okay. Now let's talk about longitude. We all know that the imaginary line drawn on the earth, there are two lines, is it or not? One is latitude and another one is longitude. So we will be talking about longitude only because we are going to learn how to calculate the time. And longitude helps us to calculate the time of the world. Now this is eastern side and this is western side. This is northern side. So we all know that the vertical line that is drawn on the earth, or the imaginary line that is drawn on the earth, is longitude, no? So there are how many longitude altogether?
360.
Altogether there are 360 longitudinal lines, and these 60 degree longitude line complete 1 day. No, the rotation completes 1 day. That means 24 hours. So 360 degree equals to how many hours? 24 hours. Is it or not? So that's why 1 degree equals 1 hour equals to 15 degree. Is it or not? And 1 degree equals to 4 minutes. Now let's talk. In the past, sun used to help to determine the time of the world. No, the people, they used to see the direction of the sun, the length of the shadow, and they used to determine the time. But later on, when they travel from one place to another, when they started their trade in other continent, the train schedule and the ship, the time of the, for example, A point of a train station and B point of the train station or any ship or train, no, when they started trading, the calculation of time became very difficult for them. Alright? Then there emerged the concept of what? GMT. There emerged the concept of GMT. In 1884, there was a Meridian Conference in USA, Washington. Okay, so 26 countries of the world, they were present there to talk about the issue how to convert the time illusion or problem of calculating the time. Alright, and they came upon the GMT. Okay, they talked about Greenwich Mean Time. And 26 countries of the world, they accepted GMT. Okay, and those countries introduced the GMT concept by law in their constitution. And even our country also follows GMT concept. And when there is, let's say this is 0 degree, GMT, what is the time difference between GMT and our country, Nepal? Which hemisphere does our country lies? Why? Our country lies towards the eastern side. Okay. So, towards the eastern side, the time is always ahead. Is that or not? And towards the western side, the time is always behind. So, since our country lies to the eastern side, our country's time is 5 hours. 5 hours, 45 minutes ahead of GMT. Okay. Now let's look at a globe. So this is a small model of the earth. Is it or not? So the sun, which directly faces to this longitude, have what? Daytime, noon. Okay. And just opposite to the 180 degree longitude, it has a midnight. Why? Why is it so? Because the earth spins from west to east. That's why the eastern side the time is ahead, and to the western side the time is always behind. Okay. So suppose if there is 12 noon in Nepal, what will be the time opposite to the 180 degree over here? Yes, midnight. Because the earth spins from west to east. And Nepal, like, okay, now let's talk about more about GMT concept. This is 0 degree. This is GMT, we call it, no, and it's also called prime meridian. Prime means first, no, since it is the first meridian, this is base for all the meridian. That's why it is called what? Prime meridian. So we talked just now, to the eastern side there is always what? Ahead. No, toward the western side there is always behind. The time is always behind. And some countries of the world, example Russia, Canada, right, which covers the largest territory, sometimes they adopt more than one standard time. Why? Why do it?
Because they are
Yes, because the land is extended, the large territory is covered by the land portion. Okay, and our country, see Nepal, it lies to the which longitude? From 80 degree to 88 degree, and it has adopted 86 degree longitude as its standard time, which is the longitude of Gauri Shankar Himalaya. Okay, so since our country lies either to the eastern side, it is always ahead than the time of GMT. Okay, and to make the now let's talk about the world time zone map. Okay, so this world time zone map is followed by various countries to calculate the time of the world in a easy way. Okay, so 12 hours to the eastern side, 12 time zones to the eastern side, and 12 time zones to the western side. So 12 time zones, like 1 hour time zones difference is there, 15 degree, which is it or not? So 15 degree equals to how many hour we have taught? 1 hour. No? So for example, you can see over here world time zone. See here 0 degree to 15 degree, that is 1 hour time difference. Is it or not? So this 12-hour time zone helps to calculate the time of a certain country if we know the longitude of a certain country. So if that lies toward the eastern side, we can add more time to GMT. And if any country that lies to the western side, and if we know the longitude, then we can calculate easily by deducting the time zones. Okay. Now let's see the video that is based on GMT concept and world time zone. Then you will be more clear about it. Okay. Thank you.
In the old days, each town would keep their own times, with a town clock being set to noon when the sun reached its highest point in the sky. However, by the late 19th century, rail had begun to move people across great distances. Schedules became very confusing, as each stop was based on a different town's time. Thus, a need emerged to standardise time so rail could operate more efficiently. In 1884, delegates from 26 countries met in Washington, D.C. to agree on a prime meridian as a common zero point for longitude. The result was Greenwich, England, being selected as the international standard for 0 degrees longitude and established the 24 time zones. Today, most countries follow the hourly deviations, though they do not always align with longitudes for reasons such as keeping the entire country in one time zone or altering times at certain times of the year, for example, daylight savings time. Time zones are based on the fact that the Earth moves 15 degrees longitude each hour. Since there are 24 hours in a day, there are 24 standard time zones. Time zones are counted from the prime meridian, which is 0 degrees longitude. Each time zone is counted at 15-degree intervals and extends 7.5 degrees either side of the central meridian. For example, Sydney, Australia, lies in the 150 degrees east central meridian, and the time zone includes all locations between 142.5 degrees east and 157.5 degrees east. Now, I will show you how to calculate time zones. First, determine whether the time zone is in the eastern or western hemisphere. If the time zone is east of the prime meridian, such as Australia, it will be at an earlier time than Greenwich Mean Time, or GMT. If it is west of the prime meridian, such as Canada, it will be a later time. Second, count how many time zones away from Greenwich the location is. For example, Greenland is one time zone to the west of Greenwich, so I will subtract 1 hour from GMT to determine the time there. Oslo in Norway is one time zone to the east of Greenwich, so I will add just 1 hour to the current Greenwich Mean Time. When counting the number of time zones away a location is, count the time zone your location is in, but do not count the time zone that Greenwich is in. For example, I will count for Buenos Aires, Argentina. 1, 2, 3, 4. So, if the time is 4:34 GMT, I will subtract 4 hours to find out the time for Buenos Aires. The time will be 0:34. The international date line is an imaginary line lying 180 degrees in the line of longitude, on the opposite side of the Earth to the prime meridian. This line separates one calendar day from another. The international date line deviates in places to avoid crossing any land. In 1994, Kiribati shifted the date line 2,000 miles east to keep the entire country in the eastern hemisphere. In 2011, Samoa and Tokelau skipped a day and moved westward to be in the eastern hemisphere so they could have the same date as Australia and New Zealand, their main trading partners.
The best means of measuring time is by the movement of the Earth, the Moon and the planets. The Sun regularly rises and sets every day, and naturally, it is the best timekeeper throughout the world. Local time can be reckoned by the shadow cast by the Sun, which is the shortest at noon and longest at sunrise and sunset. When the prime meridian of Greenwich has the Sun at the highest point in the sky, all the places along this meridian will have midday or noon. As the Earth rotates from west to east, those places east of Greenwich will be ahead of Greenwich time, and those to the west will be behind it. The rate of difference can be calculated as follows. The Earth rotates 360 degrees in about 24 hours. Which means 15 degrees an hour or 1 degree in 4 minutes. Thus, when it is 12 noon at Greenwich, the time is 15 degrees east of Greenwich, which will be 15 into 4 is equal to 60 minutes, that is 1 hour ahead of Greenwich time, which means 1 p.m. But at 15 degrees west of Greenwich, the time will be behind Greenwich time by 1 hour. That is, it will be 11 a.m. Similarly, at 180 degrees, it will be midnight when it is 12 noon at Greenwich. At any place, a watch can be adjusted to read 12 o'clock when the sun is at the highest point in the sky, that is, when it is midday. The time shown by such a watch will give the local time for that place. You can see that all the places on a given meridian of longitude have the same local time.